Focus this last unit in our trimester on quadrilaterals. So there's a couple different quadrilaterals, but this is the flow chart that you eventually are going to get very comfortable with when trying to solve your problems, answer your questions. You want to start to think about this quadrilateral list. So what you're going to ask yourself is, how many sets of parallel sides does it have? And you're either going to say 0, 1, or 2 sets of parallel sides. Now today's focus is definitely going to be on 2 sets of parallel sides, but we'll go into the other figures later on. And I'm going to have this flow chart up every step of the way for every section in Unit 4, because if we can relay back to this every time, you will start to get a feeling of how quadrilaterals really work. So let's go here. And what we're going to start with is parallelograms. So a parallelogram we're going to get to, but let's start with a polygon. So a polygon is a flat plane, a two-dimensional shape, closed, bounded by straight sides. It does not have any curved sides. So you can see all of our sides are straight lines, okay? A regular polygon is a polygon in which all sides and interior angles are equal. Now, in these shapes, some of them are regular, but you can see this one right here, the trapezoid, is not a regular polygon. All the sides are different. But we're going to start talking about the interior angle sum, which we've already done this beautiful beast in Unit 3, and it's a triangle. So when we talk about a triangle, we know the sum of all 3 angles in a triangle is the same measure every single time. So we'll call this a triangle, and given the interior, give the sum of the interior angles is going to be 180 degrees. This is going to be our jump off point for the rest of the stuff, because what we're going to do is we're going to divide these figures into triangles. Because if I do that, look at this. Here's a triangle on top, and then here is a triangle on the bottom. What do we know about all the measures inside a triangle? Well, that's 180. Same thing on this side, 180. So your quadrilateral is 360 degrees. Okay, the next shape is our number of sides is going to be 5, and that's the ever famous pentagon. And I put the pentagon in here, and I tried to show you how the 5 corners will create this pentagonal shape. And let's change the color so we can see it a little bit. But here, ooh, no. Go up a little bit. Make it bright. There's another side. There's another side. Here's another side. And then here is our 5th side. So we have 1, 2, 3, 4, 5 sides. Okay? So when we do this, what we're going to do is we're going to pick one point, and we're going to go to all of the other points. Now, if I draw this one, it's just this side. And if I draw that one, that's just this side. Oh, thank you for the likes. So thankful. But each triangle is 180 degrees. 180 and 180. So now we have 3 triangles in this 5-sided figure. So if I have 3 180s, so if I add another one, that's going to be 540 degrees. So I know, and when I'm looking at this, like the outside angles are all going to, or the angles that are inside the shape are all going to add together to give you 180 degrees. Now, if we look at the quadrilateral for a second, what that's saying is if I have angle 1 plus angle 2 plus angle 3 plus angle 4, all 4 of these, when I add them together, are going to be 360 degrees. Now, that doesn't mean they're all equal to each other. They can be different sizes, But when I add them all together, they all better equal 360 degrees or it's not a quadrilateral. And then the same thing with this figure, this pentagon. If I add all 5 angles together, it should be 540 degrees when I'm all said and done. 6 is a hexagon. 7 is a heptagon. Octopus is an octagon. A 9 is a nonagon. Then we have a decagon. And then we have a dodecagon. And what we're trying to do here is I'm trying to start you down a path where we can find the sum of the interior angles for any figure whatsoever. Okay? So what we're going to do is separate the hexagon. And think about this. How many triangles am I forming with a 6-sided figure? So I have 6 sides on this, but I only have 4 triangles. So 4 triangles is 4 times 180, which is equal to, is that 720? And then a heptagon is a 7-sided figure. So 1, 2, 3, 4, 5 triangles. So 5 triangles is 5 times 180, which will be 900. And then an octagon, the most famous one is your stop sign. There's 1, 2, 3, 4, 5, 6. So my 8-sided figure turns into 6 triangles. And then 6 times 180 is 0. 8 times 6 is 48. 1080. Okay, then my nonagon, which is 9 sides. So if we have a quadrilateral, and let's fix these up for a second. We have 1 triangle, which is 180. The quadrilateral gave us 2 triangles. So 2 times 180 was 360. And then the pentagon gave us 3 triangles, which is 3 times 180. So that was 540. So if I had a 9-sided figure, what would I do? Well, if I have an 8-side, it had 6 triangles. A 7-side had 5 triangles. A 6-side had 4 triangles. So my guess is if this was 6 triangles, this is 5 triangles, this is 4 triangles, this is 3 triangles, this is 2 triangles. You hopefully see the relationship that if I have 9, I want to subtract 2 from it and get 7 triangles. And if I have 10, subtract 2 from it, that's 8. If I have 12, subtract 10, or so 2 from it, and you get 10. And if I had n sides, I want to do n minus 2. Okay? And that would be triangles. So I'm going to do 7 triangles, and we know that the triangle is 180. So what is that? 0, and then 7 times 8 is 56. Carry the 5. That's 1260. Then 8 triangles is 8 times 180. 8 times 0. 8 times 8 is 64. And then 1440. And 10 triangles would be 10 times 180. So just add a 0 at the end of it. And then n minus 2 times triangles is we're going to do n minus 2 times it by 180. So whatever our number of sides are, we're going to subtract it by 2 and times it by 180. So that's how we're going to find the sum of the interiors for any shape whatsoever. And I know it's a long drawn out list, but hopefully you can start to see why it is the way it is. So where did they come up with this equation, n minus 2 times 180? This is how it gets formed. Everyone say hello to Sawyer. Hi, say hi, Sawyer.
Hi.
Okay, now I need to go finish work.
Okay, bye.
Bye. So we're going to use that angle sum theorem to answer the following question. So what is the sum of the interior angles of a heptagon? Well, heptagon is our 7-sided figure. And our 7-sided figure, we did 900 degrees. So we can just put 900 here. You could do n minus 2 times 180. Put 7 minus 2 times 180, which is 5 times 180, which is 900. The sum of the interior angles adds up to 3060. How many sides does this polygon have? So we know the sum of the interior angles. We know the equation for the sum of interior angles. So now what we're going to do is we're just going to solve for our n. Now you could distribute the 180 in here, or you could just divide both sides by 180 to start with. And we're going to do 306 divided by 18. Desmos. What did I say it was? 306 divided by 18. 6 divided by 18. Or we could do 3060 divided by 180. And hopefully you'll see that both of them do turn out to be 17. So when I do this, here's my equal sign. I'm still going to be left with n minus 2 equals, and then this is going to be 17. I'm going to add 2 to both sides, and that means I have a 19-sided figure for the interior angles to equal 3060. Okay, so how many sides does this polygon have? It has to have 19 sides in order to get 3060 degrees inside that triangle. What is the sum of the interior angles of a 14gon? So we're going to do n minus 2 times 180. This time we know the number of sides is going to be 14, so we're going to substitute that in. And then that's going to give us 12 times 180. Once again, that's, I mean, I can do it, but 2160. But I want to make sure that I get the correct answer, so I don't want to accidentally make a mistake. All right, how do we feel? The sum of the interior angles adds up to 1080. How many sides does the polygon have? So give it a shot. See what you can do. So we're going to start with 1080 equals n minus 2 times 180. And let me show the other way. But I think it's good practice to show multiple ways to solve a problem. Let's distribute. So let's do 180n minus 360 equals 1080. So if we do this and we go this route, underline our variable. So we want to get rid of the 360 and the 180. The 360 is the farthest away, so let's start there. And that's going to leave us with 180n equals 0, 4, carry the 1, 4, 1440. Okay, then divide by 180 on both sides, because that will one out the 180s, and I'm left with n equals, and we're going to do 1440 divided by 180 and get 8. So if the sum is 1080, then that means we have an 8-sided figure. Does that agree with what we did earlier today? Sure does. So hopefully at least that will give us a little solace that we're doing the right steps that we need to in order to find the sum of the in interior angles, the ones that are inside the figure, okay? Outside is going to be a totally different number, so make sure you're talking about the inside. All right, now determine the unknown angle measures. So remember, once again, how many sides do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have a 9-sided figure. If I have 9 sides, that means I have a total of 1,260 degrees. So 1,260 degrees equals angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 plus angle 9. Now, we can look at that and go, oh my goodness, but there's only one variable. And we still have the 2 sides of our equation, so let's keep that variable. Plus, and then let's combine our like terms. I'm going to move just over here off my screen for a second. I'm going to just type it in. 125 plus 130 plus 172 plus 200 plus 140 plus 102 plus 98 plus 135. We can double check my math. Oops, or not. There we go. Double check my math, but we should get 1102. Please always check me. So I get 1102 equals 1260. Now subtract 1102 from both sides, and that solves our problem. And we can figure out 1260 minus 1102 equals 158. So that means this angle measure should be 158. Double check me, make sure it's correct. But we know for a 9-sided figure, we know for a matter of a fact, our 9-sided figure better be 1260. So, oh my God. Oh, I just need to go back here. So when I add all these together, it better be 1260. So if I say that this angle measure is 158 and I add all the rest of these up, it better equal 1260, which it should if we did our math correct. Now, next problem, we have boxes in each of the corners, and boxes should be a good indicator to us for angle measures of 90 degrees. And then I've got an X and I've got an X, but I know it's a 5-sided figure. So let's go back. 5-sided figure is a pentagon. We know all of them should add together to give me 540. So 540 is going to equal 90 plus 90 plus 90 plus X plus X. Now, do we have to write all that out? I kind of think you should, but if you want to go 270 plus 2x, that's okay. But I want you to understand where everything's coming from. So by writing it all out, you're organizing your brain to show where everything's coming from. So now our next step, we're going to subtract 270 from both sides. And that's going to leave us with 2x equals, borrow, so that becomes a 2, and then that becomes, so 270 is what I get mentally. Then I'm going to divide by 2 on both sides. 135. And if this is 135 and this is 135 plus 90, 90, 90, look at 135 plus 135 plus 90 plus 90 plus 90 equals 540, which at the beginning of the problem we said was going to be 540. So there's another way to double check to make sure we did this correct. Determine the measure of the 4th interior angle of the quadrilateral. We know the other 3 measures. So take 360, subtract, 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 and what you're left over is the answer. 89, 80, 89, 80, 104. Should be 78 degrees if it's 104. Yeah, so 78 degrees. What is the measure of each angle in a decagon? So a decagon is a 10-sided figure. Okay. And our 10-sided figure, we said, was 1440. So we know that the sum is 1440. And they want to know what is the measure of each angle. Well, when it says regular, that's when your alarm bell needs to go off. And a regular figure means that every angle is the same measure. So all 4 of these will be 90 degrees, and that's how you get 360. Well, if I have a 10-sided figure and all 10 of them added together gives me this, then all I need to do is divide by 10, and the answer I get is the angle measure for each angle in a regular figure. Regular means that they're all the same size. And you can see from this, like, sometimes they're not all the same size. Sometimes they're different sizes. So you have to be able to accommodate for that to get the answer. Now, this one, we have 1, 2, 3, 4, 5, 6 sides. So if we go to our 6-sided figure, that's a hexagon, and the sum is going to be 720. So I do know that this right here is 720 equals 3x plus x plus 2x plus 3x plus 1x plus 2x. So still 720. But now let's combine like terms. So if all of these are x's, even though we don't know the measure of it, we could combine them all together. So there's 3, one more makes 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 x's. So then to get rid of the 12 next to the x, we're going to divide both sides by 12 so that we can get the x value there. So if we do 720 divided by 12, our solution becomes 60. So we know that x is 60 degrees. And if we have 2 x's, that's 120. 3 x's, that's 180. So this would be your answers for x, 2x, and 3x. And it might not make sense for the figures, especially when I have an angle that's a straight line. But that's neither here nor there for the problem. They gave you this problem. You just need to find x, 2x, and 3x. Don't worry if the answer realistically doesn't make sense. Because if I have a figure and it needs an angle, but you're telling me that angle is a straight line, then that's not really an 8-sided figure. It's really not. It's only just depends on the number. And because we have 2 of them, you're actually taking 2 of these angles away because they're really straight lines instead of where there should be an angle. So that's probably a little bit much, but just ignore that. What we're doing for this problem is just solving for the x, plugging it in for 2x, and then plugging it in for 3x. Okay? So these are for any polygons, regular or not. Okay? Now we're actually going to get into a very specific polygon. And this specific polygon is a quadrilateral. Quadrilateral is a 4-sided figure. So any 4-sided figure will fall under the umbrella of a quadrilateral. So when we look at this, what is a quadrilateral? All of these are quadrilaterals. They're just, you have to start to go in a specific route to understand which quadrilateral you're looking at. Because the different ones have different accommodations and can do different things. A trapezoid can't do the same thing as a square does, but vice versa. A square can't do the same thing a trapezoid does. So you have to kind of be able to separate them and figure out which is which. So, for a parallelogram, and has two pairs of parallel sides, and they will do double arrows to indicate that they are parallel. And sometimes they'll do double arrows twice to demonstrate that this line is parallel to this line, but is not parallel to the other two. That's why they make different sets of double arrows. So this one only has one set of double arrows, where the red one has two sets. It's just telling you that these two lines are parallel with each other, but are not parallel with these two lines running side by side. So it's a way to differentiate between the two sets of parallel lines. A diagonal is a line that connects two non-consecutive vertices in a polygon. So drawing your line through it is a diagonal. So, theorems of parallelograms. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So JM, segment JM, segment KL, these are congruent. JK, ML, they're congruent as well. Now, opposite sides might be equal, but that doesn't mean the tops are going to equal the sides. They could be different lengths. This could be 5 and 5. This could be 7 and 7. All I know is that the top is equal to the bottom and the right is equal to the left. I don't know if the left is equal to the top. Okay? Then, if a quadrilateral is a parallelogram, so we have two sets of parallel sides, then opposite angles are congruent. So angle J is going to be congruent to angle L. And angle M is going to be congruent to angle K. I don't like how tiny those letters are, so I'm going to rewrite it. Angle J is congruent to angle L. Angle M is congruent to angle K. So these opposite angles are congruent. Then we do know, because of parallel lines, like once again we have a history lesson coming on. I know these are parallel lines, okay, cut by a transversal. I've got a U shape. And what do I know about the U shape? It's 180 degrees. So angle J plus angle M equals 180 degrees. M and L, I could do the U shape this way, equals 180 degrees. K and L, do the opposite side. K and L is 180 degrees. And then the top angle and the top angle, one on the left, one on the right, also equal 180 degrees. So you can form those U shapes. And then if it's quadrilateral as a parallelogram, then the diagonals bisect each other. So this is where this one, these JN and LN bisect each other. And then MN and NK bisect each other. And what I don't know is if this is the same length as that. So I do not know if MN and JN are the same length. And even if by eyeballing it right now, you look at it, it doesn't look like they're equal. That is true. And it's not until we get into a rectangle that we'll learn specifically that they do bisect each other, where this, and this are all equal. But that's not for today. For today, you just learn that one side is equal to the other side, one side is equal to the other side. So I can promise you, if you have a parallelogram, that this side is going to be equal to that side, And then this side is going to be equal to that side. I do not know if pink is equal to blue, though. But I do know pink is equal to pink, blue is equal to blue. Okay, so let's start to apply some of this information. So what can we say? If this is 80 in a parallelogram, then this is going to be 80 as well, because opposite angles are equal to each other. Then, if you want to take it a step further, look at the U shape. I know the U shape is 180, so that means this angle has to be 100 degrees, because 100 plus 80 equals 180, and then opposite angles are congruent, so this would be 100 as well in a parallelogram. Then DC is 8.3, so that means EB has to be 8.3 in a parallelogram because opposite sides are equal. I do not know if this is 8.3. I do not know if that is 8.3. The only thing I can prove off of parallelograms is that this side is congruent to that side. Okay, now we talked about this. This is 112. This is going to be 112. Then we have a U shape. So angle M plus angle L equals 180. It's a U shape. Angle M is 112 plus angle L. So I'm going to subtract 112. And angle L is going to equal 68. So this is 68 degrees. And this is 68 degrees. MV is 7. VK, 7. Diagonals bisect each other, so I know these two are congruent. 23.1, this is 23.1. Opposite sides are equal. VXV is 30.4. So if I broke it in half, this would be 15.2 and 15.2. So whether I'm looking for XB or VB, both of those are going to be 15.2. This one's looking for BX, which is what we just said. Okay, next problem. Ooh, angles. Oh, shoot. I did not mean to do that. Angles, opposite angles are equal. So 6y plus 5 equals 8y minus 17. So if I highlight the y's and I draw a line down the middle of the equal sign, then what I want to do is move all of my y's to one side. And if I do that, I'm going to be left with 2y minus 17 equals 5. Then start to move the other numbers. So I'm going to add 17 to both sides. Okay, if I do that, then I get 22 equals 2y. And then last step, get rid of the 2. So I'm going to divide both sides by 2, and then y is going to equal 11. Okay, so if y equals 11, and I want angle D, then take 8y minus 17. And we already know y equals 11. That's what we just said. So 88 minus 17 is going to be 71. Now for x, same thing. Opposite sides, I know, are equal to each other. So I'm going to have 5x plus 19 equals 7x. And now move all of the x's on one side of the equation. So 19 equals 2x. It's okay. You don't always get nice numbers or nice answers when you do this. So x is going to equal 9.5. When I do 19 divided by 2, 19 divided by 2, I'm going to get 9.5. So now when I plug it back in, if I do 7 times 9.5, I'm going to get 66.5. And why? Because this is 7x. So 7 times 9.5, or 7x, x is 9.5, is, I'm sorry, I forgot already, 66.5. So that means BC is 66.5. Okay, so you can pause the video, try and apply it, but same kind of thing. Diagonals bisect each other, so this is equal to that. So x plus 9 is equal to 4x minus 6. If we underline the variables, draw a line down the middle of the equal sign, break up the equation, we can see the x's are on opposite sides. So that means I want to throw all the x's on one side, throw all the numbers on the other. And you can do it either way. I don't like negatives, so I'm going to subtract 1x from both sides. That will zero these out. 9 equals 3x minus 6. And then the x's stay positive. Then I'm going to add 6 to both sides. So I can get 3x by itself. That's 15. And lastly, get rid of the 3 in front of the x. I'm going to divide both sides by 3. And x is going to equal 5. So if x is 5, plug it back into this one. 5 plus 9 is going to be 14. Is PT and TR. So PR, the whole thing, is going to be 28. Because PT, a piece, plus a piece equals the whole thing. Alright, now let's find Z. So if we look at this side is equal to that side, because opposite sides in a parallelogram are equal. So 2z plus 4 equals 3z minus 4. Underline the variables. Draw a line down the middle of the equal sign. And this time I'm going to subtract 2z from both sides. So I get 4 equals z minus 4. So I'm going to add 4 to both sides. And z equals 8. And then plug it back in. 2z plus 4, 2 times 8 plus 4, 16 plus 4 is 20. So QR is going to be 20. If you don't believe me, put 3 times 8 minus 4. 24, take away 4, it still gives you 20. So either way you do it, you can plug it into either side that you want. You're still going to get the same answer. All right, last one. Remember, hopefully you're not going to catch yourself and you see the U shape right off the bat. U shape tells you 180. So that is 10n plus 8n, which is 18n is 180. N equals 10. So angle S is going to be 100. Angle R is going to be 80. And then 2x equals x plus 3. Subtract x, x equals 3. So that last one is a little... it's really making sure you see the U shape. Because if you don't see that U shape, you could do a lot of things to this problem. All right, I'm going to stop recording.